Okay, so let's talk about math, but I want you to forget everything you think you know. You know, the dusty textbooks, the boring formulas. I want you to think of it as a secret superpower, a way of thinking that can help you crack pretty much any complex problem you'll ever face.
Have you ever stared at a really, really tough problem? Something that feels almost impossible, but instead of just frustration, you feel this little spark of curiosity. You know, that little part of your brain that just kind of leans in and says, I want to crack this.
Well, that feeling, believe it or not, that's the exact same spark that drove some of the greatest minds in history. And today, what we're going to do is learn how to feed that spark and turn it into a problem-solving fire that you can actually control.
So, where do we even begin? Well, the foundation of thinking like a mathematician isn't about memorizing formulas at all. Nope, it's a fundamental shift in how you see the world and the problems in it. It really comes down to these core beliefs that separate the people who get stuck from those who break through. It's about understanding that feeling confused isn't a stop sign. It's actually a clue, pointing you to the most interesting part of the problem. It's about embracing that slow, steady persistence over the whole myth of raw talent. And it's realizing there's no such thing as a math person, just a mindset of not giving up, yet.
I mean, just think about the power of that one little word. Just adding yet to I can't solve this completely changes your relationship with the problem. Suddenly, failure isn't some final destination, it's just a temporary state of being on the path to a solution.
To really see this mindset in action, let's dive into the famous story of Carl Friedrich Gauss, who, as a 10-year-old, showed everyone what it truly means to think differently.
So the story goes, his teacher probably just wanted to keep the class busy for a while, gave them this super tedious task. Now most kids would just start grinding it out, 1 plus 2 is 3, plus 3 is 6. But Gauss, he immediately sensed there had to be a better, more elegant way. He was fueled by curiosity, not just the need to get the answer.
And here's the genius of it. Instead of using brute force, Gauss saw a beautiful pattern. He paired the first and last numbers, 1 and 100. What's that make? 101. Then the next pair, 2 and 99, also 101. He realized every single pair would total 101. And since there are 50 of those pairs, the answer is just 50 times 101. All that tedious work just, poof, vanished.
Okay, so a powerful mindset, that's our foundation. Now, let's start filling up our toolkit with some real, concrete strategies you can start using right away.
This might be the single most powerful habit in any problem solver's toolkit. When a problem is way too big and overwhelming, just make it ridiculously small. Solve a tiny version of it first and look for clues.
Okay, here's a classic example. You've got 100 closed lockers. Student 1 comes and opens every single one. Student 2 closes every second locker. Student 3 goes to every third locker and toggles it. If it's open, they close it. If it's closed, they open it. And so on. I mean, the scale of this just feels impossible, right? Trying to track 100 different lockers is just a recipe for absolute chaos. So we shrink it. Forget 100. What happens if we only have 10 lockers and 10 students? Now that is something we can actually work out, maybe on a piece of paper. And when we actually map it out for just 10 lockers, something amazing happens. Take a look at the table. Locker 1 is open. 2 and 3 are closed. But then, locker 4 is open. All of a sudden, a pattern starts to emerge from all that noise.
And there it is, the aha moment. The lockers that are left open are 1, 4, and 9. They're the perfect squares. So why is that? Well, a locker gets toggled for each of its factors. Most numbers have factors that come in pairs, like 10 has 1 10 and 2 5. But perfect squares are special. They have a factor that pairs with itself, like 9 having 1 9 and 3 3. This gives them an odd number of factors, which means the door is left open in the end. By solving for just 10, we've basically cracked the code for 100.
All right, so just like shrinking a problem helps us see the pattern, our next tool helps us see the hidden rules. And it's simple. Draw it. Seriously, even a terrible sketch or a quick little table can reveal hidden assumptions and details that your brain just completely misses when you're only reading the words. Here's another classic puzzle. Now, the immediate, logical-sounding answer is almost always wrong. Most people think, okay, pretty simple. It makes a net gain of 1 foot per day. So 30 feet must be 30 days. But that simple logic, it hides a trick.
The crucial detail, the hidden secret, is that the rules change on the final day.
See, our assumption that the frog always slips back 2 feet is the trap. Once it climbs out during the day, the problem's over. It doesn't hang around to slip back down that night.
And that leads us to the answer, 28 days. Because on the morning of day 28, the frog starts at the 27-foot mark, it climbs its 3 feet, it reaches 30, and it's out. That nightly slip just never happens. A simple little drawing would have shown us that right away.
Look, we've really just scratched the surface here. But these tools, having the right mindset, shrinking the problem, drawing it out, they're not just tricks. They're the start of your own adventure in thinking more clearly, more creatively.
And your training doesn't stop here. This is just the beginning. There's an entire universe of amazing resources out there for you to explore, from foundational books like Polia's to brilliant video explainers on YouTube, and even communities where you can solve problems with other people.
Remember this: the only thing that separates you from the people you admire is that they started their journey and they simply refuse to stop when things not hard. That same potential, that same spark is right there inside you.
So I'll leave you with this question. Armed with this new way of thinking, what challenge are you going to take on? What beautiful problem will you solve first? The universe is kind of waiting to see what you discover.